Okay, so we just learned our formula for area of a sector. We're going to apply that to a couple of problems here. Here I've got this figure. It looks like a rectangle, and they've cut out a semicircle. So they just sort of cut that out on one side. We're supposed to find the area of what's left over. So we're first going to find the area of the rectangle. So area of rectangle, base times height. Okay, so that's going to be 50 times 10, 500 square inches. Okay, so that's going to be all of that area, including the semicircle. So now we need to subtract that off. So the rotation's 180. 180 over 360 is just a half. So it's going to be 1/2 of. Okay, so we need two things. We need angle of rotation. We know that that's 180. We also need the radius. You might be very tempted to say that the radius is 10, but again, that's not quite right. This is our radius, which should be half of 10. So that should be a 5. It's going to be 25 pi because your formula is pi r squared. And so to find this one shaded area to the nearest tenth, we want to wait till the very end to round off. And so in your calculator, you want to type all this in at once. So shaded area is going to be 500 minus 25 pi over 2. If you want to say 12.5 pi, that's the same thing. And then we'll type all that into the calculator. Alright, so it should look like that. So about 460.7. And make sure we have inches squared on there. Alright, that one's pretty straightforward because there wasn't a whole lot of work coming up with the angle of rotation. Let's take a look at this next one. So here they're telling us we have a segment that's tangent to our circle. Okay, so we need to remember from last chapter that means if you have a radius, any line or segment that's tangent to your circle is always going to be perpendicular to that radius. And we know that AB is 34. Okay, so this whole thing is 34. And they want us to find the area of all of the shaded region. Okay, so the tricky part about this is we need to figure out what is this angle of rotation. Because the two things we need, formula is angle over 360 times pi r squared. You need the radius, you need that angle. So if you don't have those two things, you can't really find the area of that sector. Okay, so let's go ahead and find them. If that's 30 and that's 90, okay, well that's got to be 60. Angles in a triangle always add up to 180. So that means this rotation has got to be 300. So far I know that much. 300 over 360 times pi. Okay, now we need to figure out what the radius is. You can do that a couple of different ways. The easiest way is, notice this is a 30, 60, 90 triangle, which means this is my short leg, this is my long leg, that's my hypotenuse, and we should remember that the hypotenuse is always double the short leg, so your radius is going to be half of 34, because this is always half of my hypotenuse. 17. So that's going to be 17 squared, or 289, however you want to think of that. If we type all that into the calculator at once, 300 divided 360. Okay, so it should look like that when you plug it in, which is about 756.6. And since, let's see, they put the little m for meters, that's the length of AB, I should say meters squared. Alright, so last one here. We have a pizza with a diameter of 18. and it's supposed to be cut into 12 equal sized slices. What's the area of one slice? So here's our pizza. We're going to slice that thing a whole bunch of times. Okay, so that's 8, and then we can keep going and going and going. We want to, oh, I'm sorry. Supposed to cut it into 12 equal size slices, not 18. So we're going to cut that. Really, all you need to know is this is going to tell us how to find the angle or what portion you're looking at. So we're going to look at a lot of ways you can think of it. You can do 360 over 12 and see that each angle is going to be 30 degrees. Or another thing you could do is you could think of it as all of the area divided by 12. Because whenever you cut that into equal slices, I know I have 8 on here and we're supposed to have 12. But however many pieces you cut it into equally, you can just divide by that number. The diameter is 18, which tells us the radius has to be 9. So we're just going to do pi r squared, in other words, 81 pi, because that tells us r equals 9, and 9 squared is 81. We're going to do that divided by 12. And so this is going to be the area of one slice. We can reduce that fraction. Let's see, 3 goes into the bottom 4 times, into the bottom 27 times, or sorry, top 27 times. Okay, so they didn't tell us to round on this one. They should have. Go ahead and type that in our calculator and then round off at that point. And get an estimate for how big one slice is. So let's see what that is. I'm getting about 21.2 square inches. Okay, that should give you plenty of information, good jumping off point to get all those problems in the assessments and all the post-lesson questions done.